Welcome to solverfy.
Solve the problem regarding the car which is moving down alongside a cliff and then it unfortunately falls into the water. So first we have to calculate the velocity of the car when it reaches the uh, the bottom of the cliff. So this velocity v1 can be calculated as following: the length of the cliff L equals to v1 squared minus v0 squared divided by 2a, or due to the fact that the final initial velocity is 0, it is v1 squared over 2a. Then v1 equals to the square root of 2al, or square root of 2 times 53.0 meters times 36.3, no, sorry, 3.63 meters per second squared. Let's calculate this velocity. It equals to 19.6 meters per second. Okay, we've solved question A. Now 4 more to go. Let's find the time which is needed to reach the bottom of the cliff. So we can do it in the following way: v1 equals to v0 plus at1, or at1 because initial velocity is 0. Therefore, t1 equals to v1 over a, or 19.6 meters per second over 3.63 meters per second squared. Let's calculate this number. Or actually, no, that's everything. Yeah, never mind. It's 5.399 seconds, so 5.40 seconds. Okay, we've solved question B. Now we have to find question C. Now we have to solve question C, which asks us to calculate the velocity v2 when the car reaches the ocean. So after this point 2, the car will be the trajectory of the car will be parabolic. And if we introduce y and x-axis directed as shown here, then v1 y equals to v1 times cosine alpha, because here again let's redraw this projection here. So let's redraw this. Yeah, that's the top of the cliff. Here the car has a velocity of v1, so here is angle alpha, so therefore v1 x equals to v1 times cosine alpha, and v1y equals to v1 times sine alpha. Okay, that's done. Now let's write down evolution of these functions as a function of time. So here, okay, for the simplicity, let's consider this motion which starts to occur at some time t prime equals to 0. At this t prime equals to 0, v0 equals to v1. So basically what we do, we just shift the axis. We just shift the time scale, but it just helps us to solve the problem, but we are not doing anything wrong. So therefore v0 x equals to v1 x, which is v1 times cosine alpha, and v0y equals to v1y, which is v1 times sine alpha. Now the velocity vy as a function of time equals to v0y plus as a function of actually t prime here. V0 equals to v0y plus g, because it's the only force which is exerting after the end of the cliff is the gravity. So therefore, the acceleration, vertical acceleration, is g. And Vx as a function of t prime equals to v0x, and that's constant. So now we have to calculate t prime time, which is needed to cover the height of h0, so basically to reach the ground. We need to calculate time and the velocity at the end. So let's redraw this system. So here is the initial point where t prime is 0, and then the car reaches the ground somewhere here. Sorry, it reaches the ocean somewhere in this point, and in this point it has velocity of v2, which we have to calculate. So h0 equals to v2y, or y component of the final velocity squared minus v0y squared divided by 2g, because so basically that's this is the final vertical component, this is the initial vertical component during the free fall. So therefore now we can calculate this guy. So 2gh0 equals to v2y squared minus v0y squared. Therefore, v2y squared equals to 2gh0 plus v0y squared, or it equals to 2gh0 plus v1 times sine alpha squared. Let's calculate this value, and we'll just end up with a square root. We won't take the square root because we don't need it. So equals to 10 meters per second squared times 2 times h0, which is 30.0 meters, plus v1, which is 19.6 meters per second, times sine of alpha, which is 37.0 degree, all squared. Let's calculate this number. It equals to 739.1 meters per second squared, meters squared per second squared. Now let's find v2x squared. So it equals to v1 times cosine alpha squared, because this horizontal component is doesn't depend on time, or it equals to 19.6 meters per second times cosine of 37 degree squared. So let's calculate this number. It equals to 245.0 meters squared per second squared. So now let's look at this triangle formed by v2x and v2y. So the velocity v2 is the hypotenuse of this right triangle, and v2 equals to the square root of v2y squared plus v2x squared, which we've already found these components. These are 739.1 plus 245.0. Now, yes, it will be in meters per second, and we can calculate finally this number. Yes, it's been quite a long solution, but that's a long problem as well. It equals to 31.4 meters per second. Now let's find this angle alpha. Or actually, let's label it angle beta, which is angle to the horizontal, to the angle to the horizon. So beta equals to a tangent of v2y over v2x, or it equals to a tangent of square root of v2y squared over v2x squared, which is a tangent of 739.1 over 245.0. So now we can finally calculate this number. It equals to 60 degree. No, 60.1 degree. So then beta is 60.1 degree. That's the angle with the horizon. And obviously it's below the horizon. So we finally solved question number C. Now we have two more to solve, but now it will be faster because now we have to find total time of flight, total time of the displacement, and it equals to T1 plus T2, where T2 is from the top of the cliff time needed to go from the top of the cliff to the ocean level, or it equals to, or if we here, if we look at this picture, so this time which is needed to cover the distance of h0, which with the initial velocity of v2y and acceleration of g. So therefore h0 equals to v1 times sine alpha times t2 plus gt2 squared. Okay, now we have to calculate t2 from this equation. So let's do this. h2 is 30 Yeah, everything in the SI, therefore we can just substitute parameters with the numbers. So h2 is 30 meters, it equals to 19.6 times sine of what's the angle? I've already forgot it. 37.0 degree times T2 plus 5 T2 squared. So let's rearrange this quadratic equation. So let's calculate the discriminant of this quadratic equation. It equals to 11.8 squared plus 4 times 30 times 5. So it equals to 339, oh sorry, 739.1. So therefore T equals to 11.8 plus square root of this number divided by 10 or divided by 2 by 5. So again, there is only one solution which makes sense, because if we have a negative sign here, this time would be negative. It equals to 3.90 seconds. So that's T2. So therefore total time equals to T1, which we've already calculated, I believe. Yeah, 5.40 seconds. 5.40 seconds plus 3.90 seconds. So let's calculate it. It equals to 9.30 seconds. Okay, that's good. Like now we have to calculate only the distance of the flight from the bottom of the cliff. So this is L, and it equals to V1 cosine alpha times T2, or 19.6 meters per second times cosine of 37.0 degree times 3.90 seconds. So let's complete this calculation. It equals to 61.0 meters. So that's the solution of this problem. I hope I helped you. Thank you very much for your attention.